All right, welcome back to Math 160. We are going to continue working on Chapter 3. We left off on page 10, Part B. As a recap, take a look at Part A. We were given that women's heights are approximately normally distributed. You're told that you have a mean of 64 inches and a standard deviation of 2.7 inches. So for the first part, Part A, we wanted to find the probability that a woman chosen from the population would be between 68 and 71 inches tall. So let's take a look at Part B. We want to find what percentage of women from this population. Notice the language, what percentage of women. In Part A, we were asked, what is the probability? So that's the difference between having a decimal versus having a percentage, right? Converting that decimal into a percent. So consider that as well. What percentage of women from this population would you expect to be more than 71 inches tall? So when we think of this idea, essentially, we're going to start with calculating the probability that the height is more than 71 inches tall. I would love for you to talk me through maybe the first step. What's the initial step that I have to take in calculating the percentage? Oh, Lucy, great call. Thank you for reminding me on that. Beautiful. Okay, beautiful. Thank you, Lucy. So what's our first step? Sam, what's the very first thing we should probably do? I want the probability that the height is greater than 71. Where do I even begin?
I guess you'd find the probability that it is 71.
Which means we need to find its corresponding z-score. Yes, Sam's correct. The cool thing is, look at Part A. You calculated it already. Okay, cool. So if you know that when x is equal to 71, you know that its z-score is equal to 2.59. I'm not going to rewrite the work because we literally have it up here. You can rewrite it if you would like, but we've already found the z-score. Again, what may help is to draw the actual curve. So I'm just going to quickly draw our normal curve. Here it is. 0, 1, 2, 3, -1, -2, -3. We're going to plot the point 2.59. That's approximately here. We draw the dotted line up. Now, the cool thing is we found that probability to the left already. So notice here where z-score is 2.59, the area to the left is 0.9952. We already calculated this. So let's write out that the area to the left is 0.9952. Let's shade the appropriate region. We want x to be greater than 71. So that means we want the region above. We want to shade the region in the tail. Kelly, if I know that the area to the left is 0.9952, what is the area to the right? And how do you calculate this?
I was just going to ask, how did we get to 0.9952?
Oh, perfect. We will actually just go to our z-score table.
Oh, that's right.
Yep, and that's okay. I will show it just because it's been.
So then we would subtract it from 1, yeah?
Yes, beautiful. That's exactly correct. Let me show the 2.59. So we have 2.5 here, and then we look at the column header. We know that 9 is the last column. So we follow this to where they match, and then 2.59 is a probability of 0.9952. Good. Kelly's exactly right. If we want the area to the right above this particular z-score, we must take 1 and subtract the area to the left, which is the same as subtracting the probability to the left. So we find that we get a probability 0.0048. Now remember, we would like to write our answer as the percentage. It's a little bit funky because it's such a small probability. You still want to multiply by 100. So multiply by 100 to convert to a percentage. So there are approximately, and what percentage are we looking at?
48.
What's that?
48.
Not quite 48%. It's actually smaller than that.
0.48%.
Yeah, which is crazy, 0.48%. There are approximately 0.48%, right? Smaller than 1% of women who are more
sorry. That's what I meant to say,
Oh.
0.48.
Awesome. Who are more than 71 inches tall. So it's a pretty small percentage, a very small likelihood out of this sample, of course. Good. I hope that this was like, oh yeah, that's right. We are totally able to find a z-score. We look at the chart. We look for the probability to the left, subtract from 1 to find the probability to the right. It's all the same stuff that we've been looking at. So let's take a look at the next practice problem. And by the way, if I'm moving too fast or you need to see the previous page, please don't hesitate to ask. Practice number 5. Let me raise this up just a tiny bit. Okay, the wait time at a local bank is approximately normally distributed with a mean of 4.7 minutes. So immediately I'm highlighting, right? And a standard deviation of 0.8 minutes. We need this information definitely in order to do this. If it helps, you could even use notation. Mu is equal to 4.7 minutes and sigma is equal to 0.8 minutes. We want to find the probability that a randomly selected customer from this bank will have to wait more than 3 minutes. So it's exactly the same as our previous problem. Okay, so let's start with the very initial step, which is to standardize that value, that raw data value. So we're always going to start with finding the z-score. And I'm going to try to make it like a list again so that we are refreshing our memories. So we're going to start by finding the z-score. We know the formula is z is equal to our raw data value. In this case, we're going to say that x is 3. We're finding the z-score for when x is 3. So it's our raw data value minus the mean divided by the standard deviation. Please punch this into your calculators and provide to me the z-score that is associated with a raw data value of 3. What do you get for this one? You can shout it out, please.
Negative 1.7
I guess something a little bit.
for the top part.
Oh, yes. And then divided by 0.3, what do you get when you finish that off? Or 0.8, what do you get when you finish that off?
I got negative 2.125.
Awesome. And in which case, we're going to round to the nearest hundredths place because we need to have 2 places after the decimal so we can use that chart. So we will say negative 2.13. Beautiful. Same exact idea. Let's go ahead and draw our normal curve. So step 2 is draw curve and shade. Let's go ahead and do this. We have 0, 1, 2, 3. Let's go the opposite direction. Negative 1, negative 2, negative 3. Negative 2.13 is approximately here. We draw our dotted line up. Which region am I interested in shading?
Above.
Yeah, above. Beautiful. So we're going to shade this region here. Abby, thank you for letting me know. No worries. I'm glad you're hanging. Good. We shaded the region above. However, when we look at the value -2.13 on our z-score table, it gives us the area to the left. So Lainey, when you look at your z-score table and you look up -2.13, what is the area to the left of that z-score?
Let me pull it up real quick. Sorry.
Yeah, no, that's okay.
I have to get ready for work.
So yeah, -2.13.
Okay, I see -2.1.
Yep, and then
-2.
yeah, when you've got -2.1, go across until you get to the column that says 0.05.
Yeah. 0.01659.
Yes, beautiful. 0.01659. We want the area to the right. So just like the last problem where Kelly said, okay, well, let's just subtract from 1. We're going to do exactly that. So to find the right-hand side, we're going to write 1 minus 0.01659. So I'm going to write here step 3, find probabilities using the z-score table. And draw or write on the curve. Draw the curve, label the curve, write on the curve, whatever it takes. So we've got 1 minus 0.01659 gives us a probability of 0.98341. So lastly, we're just going to write the associated statement. So step 4, write the associated statement. What could you say in response to this particular problem? Find the probability that randomly select the customer from this bank will have to wait more than 3 minutes. How would you write your statement? What do you think? Don't be shy.
There's a
what do you-
probability. Oh, sorry.
No, go for it. You've got it.
Okay, so there's approximately a 98.34% chance that you will have to wait more than 3 minutes, or a customer will have to wait more than 3 minutes.
Yes, that's absolutely correct. I am going to keep it as a decimal only because it's requesting probability, but you're absolutely right. It's essentially the exact same thing. So there is approximately a 0.98341 chance that a customer will have to wait more than 3 minutes. Good. What questions do you have on part A? Your turn. I would love for you to complete part B on your own. It says, what % of customers would you expect to have a wait time less than 5 minutes in this bank? I'm going to pause the recording and give you an opportunity to complete part B. So here we have the associated z-score with a raw data value of 5. So I got z is equal to 0.38. Let me shade that in a little darker. So when we go to our z-score table, we're going to look up 0.38. We find that the associated probability is 0.6480. Remember that the z-score table gives you areas to the left, which is actually the region that we want. Mallory, yes, for your z-score, you always round to 2 places after the decimal because of the fact that your z-score table is only to the 100th place. So we always want to round it to 2 places after the decimal for a z-score. Beautiful. We found the area to the left is 0.6480. If we had shaded the region to the right, so maybe we wanted to say, how long would a customer, or what percent of customers would you expect to have to wait for more or longer than 5 minutes? That would be shaded to the right. But because we want to find the percent of customers that have a wait time less than 5 minutes, we're shading to the left, which is exactly what the chart provides. Okay, no worries, Jenny. So when we have our probability or our area 0.6480, we multiply that by 100 to convert to a percent. So approximately 64.8% of customers will have a wait time or will have to wait less than 5 minutes. As always, make sure you're considering the steps above. You may want to always refer back to this layout for part A. 1, find the z-score. 2, draw the curve and shade. 3, find the probabilities and place it on the curve. 4, write the associated statement. So always use that as a guide to help you work through these particular problems. What are your questions for me so far?
Can you show again how on the table where you got a
Yeah.
0.648?
Oh yeah, absolutely. So we want to go to a z-score of 0.38, right? So 0.3, and then this is 0.30, 0.31, 0.32, all the way to 0.38. So that's when we say what's the intersection of that row and that column. So that's how I got 0.6480. That's the associated area to the left of a z-score of 0.38.
Yeah, I was looking in the wrong direction.
That's okay.
Thank you.
You're welcome. That's okay. It's been a little while too. It's been like a solid week. Beautiful. Any other questions on this?
How come we didn't subtract from 1 on this one?
I love that question. So keep in mind that these z-score tables always give you the area to the left. So if your shaded region is to the left, you're solid. You have that exact probability. The only time we subtract from 1 is when we want to find the area to the right. So notice with our initial problem here, part A, we wanted the area to the right, but the z-score only gives you the area to the left. So that's why we subtract from 1.
Thank you.
You're very welcome. Excellent. Any other questions? This is great. All right, turn the page when you are ready. Okay, determining data values. So let's check this out. Suppose you want to find out the grade you need in order to be in the top 15% of your class on an exam. From past experience, your teacher estimates the mean will be 80. That's something very important. We always highlight or write out this information. The mean will be 80. So I'm going to go ahead and write mu is equal to 80. And the standard deviation will be 12. So immediately I'm writing these pieces of information down. And the standard deviation will be 12. Determine the grade separating the bottom 85% from the top 15%. That's an interesting concept right there. We want to separate the bottom 85% from the top 15%. Essentially, what that means is that the area under the curve to the left will be 0.85. The area under the curve to the right will be 0.15. So loosely, without actually labeling any numbers, because we don't know the exact z-score, essentially how we're breaking this particular curve up is like so. So somewhere around here, I would imagine, there would be 85% of the population to the left and 15% of the population to the right. If you had to guess what the z-score might be, what would your guess be? I would love to know what you think that z-score could possibly be. What do you think? Throw an idea out there. What could the z-score be?
1.0, about around 1.03, 1.04. I would say closer to 1.04 though.
You are too good. You gave me the exact answer. Can you please talk to everybody about how you got that?
I literally went to the table and I found like what was like closest to 85%, and then I just like went like I put it in the hundreds place, and then the closest one was 1.04.
Yes, I love it. Okay, check this out. Right away, you're going to go to the z-score table and you're looking for an area of 0.85, the area. So remember, that means we're back inside the chart. The cool thing is we've actually done one of these examples with a 0.85 before. We did this in a previous problem. So take a look at where 0.85 is. It sits between these two areas. We see that 0.85 is closer to 0.8508 than it is to 0.8485. We see that it's closer to this value. The z-score associated with this value is 1.04. So the process that we've taken before, he's applying to this problem yet again, because he's like, there is no difference here. It's just a fancy way of saying, well, the probability to the left of the z-score is 0.85. So he immediately goes to the table and says, well, what's my closest z-score? And that's going to be 1.04. Any questions on that concept? We've done this several times before. As you notice, we tried this for 0.90, for 0.96. You always look to see which one it's closest to. Good. So we find that associated z-score is 1.04. Now keep in mind, that wasn't the question. They weren't asking, hey, what's the z-score associated with this particular grade? They actually want to know, what is the grade, right? Determine the grade that separates the bottom 85% from the top 15%. I want you to think back to your z-score formula. The z-score formula is the raw data value minus the mean divided by the standard deviation. I want you to think about the pieces of information that you have just been provided. Using the z-score table, we saw that our z-score value was 1.04. So z has a substitution of 1.04. We don't know the grade that's associated with that z-score, but we do know the mean and we do know the standard deviation. For any of these particular problems, because the z-score formula has 4 variables, 4 unknowns, as long as you know any 3, you can solve for the 4th. Would someone help me to solve this algebraically, which by the way is why you take 096 previously? Nick.
Mind if I do it?
I love it.
So what I did was I did 1.04 times 12 to get rid of the denominator.
Yes. I'm going to write exactly what you're saying.
And then I got 12.48 equals x minus 80. And then I just add 80 and I get 92.48, which equals x.
Yes. Awesome. Brilliant. Brilliant. Nick started by multiplying by the common denominator, which is 12, because we know that it's x minus 80 divided by 12. The opposite of divided by 12 is to multiply by 12. So he's using opposite operations to isolate the variable. Perfect. We notice that 12s are going to cancel on the right. You definitely have to multiply every term by that 12. And this fraction is one whole term, which is why we place that in parentheses. You get 12.48 equals x minus 80, and then the rest is history. You know how to solve from there, use opposite operations again. Good. So the grade separating the bottom 85% and the top 15% of the class is 92.48. That is the grade separating the bottom 85% and the top 15%. If you got a 92.48% on your test, then you outperformed 85% of the rest of your class. For these kinds of problems, think about the two levels here, right? You're looking at the class as a whole, and you want to separate that class by a specific grade. That specific grade you are responsible for finding. What questions do you have on this that I can help clarify? Anything at all? And by the way, Nick, fabulous job.
Thank you.
You're welcome. Anything I can help to clarify, to make sense of what's on your mind? What can I help with?
I have a quick question.
Yes.
I was wondering, could you go back to page 11?
Yeah, of course. Right here.
Yeah. Thank you.
While Stephanie looks at page 11, continue looking at that particular practice problem and let me know if you have any questions on that. I don't hear any questions, so I'm betting that we are at least somewhat okay, or we're just being shy. And I really don't want you to do that because that just kind of hurts you, you know? If you have a question, guarantee somebody else has that same question. So don't be shy about asking. Stephanie, you good?
Yeah. Thank you.
You're welcome. Let's try it again. Practice number 6. Suppose that you want to find the grade or points needed to be in the top 10% of your graduating class. From past experience, we can estimate the mean to be 93.4 and with a standard deviation of 2.6. Good. Determine the grade separating the bottom 90% from the top 10%. So let's go ahead and draw our curve just so we have an idea of what's going on here. And essentially we want to find a z-score that separates the bottom 90%. So if I had to guess, I would say it's probably about here. So 90% of the population is to the left and 10% of the population is to the right. So that means we want to find the z-score whose area to the left is 0.90. So not Nick this time because we already know that he's got this down pat. Would someone else tell me what's the associated z-score with an area to the left of 0.90? What do you think? Emma, yes, perfect. Emma is correct. So in the chat, and she sent this to me privately, no big deal. She saw that the z-score associated with an area to the left of 0.90 is approximately 1.28. That is correct. That's a z-score of 1.28. Let me show you. So Emma went to the z-score table, and in here she scoured for 0.90. Notice that 0.90 is between these two particular areas. But we see that 0.90 is definitely much closer to 0.8997 than it is to 0.9015, right? You're so much closer to this value. So when we think about the z-score associated with this area, we see that that is 1.28. So that is the associated z-score, 1.28.
So now I have a question.
Susie.
Yeah, I mean, it's on the same table that we had because I was looking and then I automatically look at 1.3 and in the 0 column because I saw 0.90 in the beginning right there. So if we are looking, it would be the first, like it would be the lowest of the 0.90.
Yes, yes. You want to be as close to 0.90 as you possibly can.
Okay, because I was getting all these are 90 and okay, now I got it clearly.
Yes, yes, you're right. And that actually is why we have to say, okay, well, if we know that 0.90 sits between these two exactly, which one is it closest to? And then it actually is closer to this one. If you were to subtract these two, you would get 0.0003. But then if you subtracted these two, you'd get 0.0015. So
Yeah.
it's much closer to this guy.
But my question was, there are a lot more 0.90, like in the column, in the 0.13, like all those are 0.90. So it's easy to make a mistake saying it's between, you know, one of the 0.932,
Yes.
like
Yes.
that's what I'm saying.
You're absolutely correct. You're absolutely correct. So just be super, super careful. But yes, you definitely want to think of this as like a number line and then figure out like where throughout the whole region, look at the line, the row above and below too, just in case. Good. Very cool. So we have that our z-score is 1.28. So we're going to do the same thing with our z-score formula. We're going to plug in our values. So we have z, which is 1.28, is equal to the raw data value, which we don't know what that particular grade is. So it's going to be x minus the mean, which is 93.4, divided by the standard deviation, which is 2.6. Go ahead and solve this on your own, and then send me your raw data value, the grade, in the chat privately, please. Send that to me directly. Yes, awesome, Anthony. Emma, perfect. Nick, perfect. Kelly, perfect. 2 more in the chat. Sam, Abby, done. Jenny, done. Beautiful. Okay, this is a piece of cake. I love it. I love that you're like, okay, done. Multiply both sides by the denominator so that we can cancel out those 2.6s. We are going to then get 3.328 is equal to x minus 93.4. At this point, we want to solve for x. We're going to add 93.4 to both sides. 93.4 to both sides. And then we get that our raw data value is 96.728. That's my x. So the questions as I write? Okay, the grade separating the bottom 90% and the top 10% is a score of 96.728. Now keep in mind that you possibly could round. It really just depends on what you're being requested to find, but that is a possibility. So keep that in mind. You know, Lumen might say, can you round your score to the nearest whole number? And you would say, okay, the score would be a 97. If they ask you to round to the nearest tenths, you're going to say 96.7. Okay, so something like that. Just keep that in mind. That's a possibility. Fantastic. We're moving right along. As always, if you have questions, please don't hesitate to ask. I want to make sure that you're okay with all of this. You're probably thinking, sheesh, there's more. Yes, it's all the same stuff though. So I don't want you to be alarmed by this. So we're determining percentiles. What is the value of the exam grade at the 44th percentile when mu is equal to 89 and sigma is equal to 5. Okay, so keep in mind, if we want the value of the exam grade, that's x, right? We're going to draw our curve. We want the 44th percentile. If you think about this logically, what do you think your z-score would be if you want to find the exam grade at the 44th percentile? Is this z-score going to be positive or negative?
Negative.
Yes, absolutely negative. We know that if we have for instance, a z-score of 0, and I drew the dotted line up, that's 50% of the population, but we want 44. So we're somewhere around here. So we are somewhere around here where the area to the left is 44% or 0.44 area. That's what we're looking for.
You want me to speak or no? Because I already have it, I think.
Sure. Yeah, go for it. So where would you find 0.44 in your chart?
So I went to negative 0.1 and then I kind of went across to see what was closest to 44% or the decimal of 0.44.
Uh-huh.
And then I saw 0.44038 and I thought that was the closest. So I just went up and I saw, so it was negative 0.1 and 0.5 and that'd be negative 0.15.
Yes, perfect. I love this. And yes, do what Nick is doing. You know, you can write all over your z-score table just to make sure that you can feel confident about this. 0.44 definitely sits between these two scores. 0.44 is closer to your 0.44038, which has an associated z-score. And let me highlight that number, because why not? We can write all over this. These are tables. That has, that, like Nick was saying, has an associated z-score of negative 0.15. If you go to the column header right here, negative 0.15 is our z-score. So negative 0.15. So I'm going to write that down here. Z is equal to negative 0.15. We know the mean is 89. We know that the standard deviation is 5. We're going to plug it right into the formula yet again. Z, which is negative 0.15, is equal to x minus the mean divided by the standard deviation. Plug in the values you are provided, and then we'll go ahead and solve. We're going to multiply both sides by 5. Notice the 5s cancel. That gives us a negative 0.75 is equal to x minus 89. And then, of course, add the 89. When you punch this into your calculators, you should get 88.25 as your value for x. So we can say the exam grade at the 44th percentile would be a score of 88.25. Perfect. How about you do number 7? What is the value of the height at the 53rd percentile when mu is 66.7 inches and sigma is 3.7 inches? Give number 7 a shot. As you do this, I'm going to pause the recording. All right, so when we look at practice number 7, when we go to our table, we look for 0.53. Notice that 0.53 sits in between these two values. You then just want to see which one is it closest to. When you compare the distance between each of these values, you'll see that 0.53 is actually much closer to 0.5319 than it is to the other. So if 0.5319 is the closer value, then that has an associated z-score of 0.08. Donna, that's perfect. Using your z-score of 0.08, you plug that into your formula, you solve for x, and you find your raw data value is 66.996 inches, because we're talking about heights here, and we were actually given units this time. So the value of the height of the 53rd percentile is 66.996 inches. Very nice. That's fantastic. We actually only have one more topic to cover in this section, and that's the middle percentage. So instead of saying below or above, we actually want the middle. And we have kind of seen this before. So we're going to talk about this carefully. And again, if you have questions, don't hesitate to ask. This part might be a little bit tricky at first, but maybe not. We'll see. Find the z-score such that the middle 88% of the standard normal curve lies between negative z and positive z. Because it's symmetric, it would make sense that you would essentially have the exact same value, just positive and negative. So check this out. We want the middle 88%. So if we were to just, again, draw the curve, we want the middle 88%. So let's just say that maybe from here to here, that this is 88% of the data, right? What value of percent is left in the entire curve? What's left?
In the higher curve?
Actually, in both of the tails combined.
So both of them combined would be
22.
12,
Keep going.
but I'm gonna say since it's the middle 88%, it's gonna be 6 on the left and 6 on the right.
Yes, love it. Does that make sense to everyone? If the middle value of the curve is 88%, what you have left is 12%. But remember, you have two tails. So you split that in half evenly, especially since this is symmetric. So each tail has 6% in 6% of the population. What you'll want to do is you're actually going to want to start by finding the area to the left of our first z-score, because actually that's the only thing you need. Once you find the z-score associated with an area of 0.06, then its exact opposite will be the z-score where the area above is also 0.06. So I'm going to write here that this is 0.06, right? 6% is the same as 0.06. You're going to look at your z-score table. I'm going to make a note here. We will, wow, I'm so sorry. We will have to find the z-score associated with an area to the left of 0.06. So go to your z-score table. You know that that's definitely going to be a negative value. So go to the negative side of your table and try to find 0.06. 0.06. And I found it. 0.06. I'm going to write that on the table. Question. Would you tell me which two z-scores is 0.06 right in between? Look for 0.06. And you can type that into the chat if you'd like. What are the two z-scores that 0.06 is right in between? Kelly, awesome. Good. I want to see a few more answers in the chat, just to me privately. Nick, perfect. What are the two associated z-scores? Let's get 3 more responses in the chat. Mike, excellent. 2 more. Emma, excellent. 1 more. Not quite, Stephanie. You can actually find 0.06 somewhere in between two values. Even better than that. 0.06 is actually outside of that range. So keep taking a look. Sudhajini, you're pretty close. You're pretty close. Abby, yes. Okay, check this out. And Donna, you're right about it being close to that one, but I actually wanted the associated z-score. So if we go to our table, do you see that 0.06 sits directly between these two values? A 0.06057 and a 0.05938. So 0.06 is right between these two decimal values, which have a corresponding z-score of negative 1.55 and a negative 1.56. That's where we are between a negative 1.55 and a negative 1.56. When you do the math to see which one it is closest to, you'll see that it's actually closer to a negative 1.55. Yes, Nick, exactly. So it's closer to a value of negative 1.55. If the value to the left is 6% of a z-score of negative 1.5, that's going to be the same as the value to the right of a z-score. So what we can say here is that the z-scores that bound the middle 88% of the curve are negative 1.55 and positive 1.55. It's symmetric, which makes sense that they're going to be the exact same value. The area to the left of negative 1.55 is 6%, and so is the area to the right of a positive 1.55. They are symmetric. What questions do you have for me on that? Okay, try number 8. If the mean salary is $55,000, so the mean is $55,000, and the standard deviation is $7,000. What is the salary range of the middle 60% of the workforce? And actually, because we have 8 minutes left, I don't mind doing this with you. Okay, let's draw the curve. We want the middle 60%. So this is 60%, which means what percentage is in each tail? You can go ahead and shout it out. What percentage is in each tail?
20.
20%. Good. So there's 20% of the population in this tail, and there's 20% of the population in this tail. We know this because the total percentage under the curve is 100. So if 60% is the middle, then 40% gets split between the two tails. So 20, 20, and 60 make 100. Good. We want to find the associated z-score with an area to the left of 0.20. Go to your table. You know you're going to be on the negative side, and you want to find 0.20. Surajni, what are the z-scores that are on either side of 0.20? The z-scores on either side of 0.20. What do you think? And everyone should be looking at this as well.
correct?
I can hear you now.
Did you hear me before?
No,
Oh my gosh. Is it 0.42074?
we're looking for, so go to the negative
Okay,
side of your
so
table.
we are looking in between.
Yes, you're looking
Okay.
at all of the areas.
Okay.
You want to find the two values that are just above and just below a 0.20.
Can I try?
Yes, absolutely.
So would it be negative 0.8 so like 0.8 negative 0.08. No, wait a second. Am I making sense? Okay, so negative 0.8, 4
Yes, or
and 5.
yes, beautiful. Let's check it out. I've written the 0.20 here on our z-score tables. I'm going to try to scoot this down just a touch. We see that this value is in between negative 0.84 and negative 0.85. Yes, absolutely, Donna. So then we just have to decide which one it's closest to. Would that be the area to the left or the area to the right? Which one of these is it closest to?
The left.
Yes, the left. I'm going to highlight this value, 0.20045. It's closer to that one, which is a z-score of negative 0.84. Excellent, Donna. That's exactly correct. Negative 0.84, which means the opposite is a positive 0.84. While that is all fine and dandy, that's actually not the question being asked. We need to take this a step further. We want to know, what is the salary range at these values? So what you're going to do is you're going to find the raw data value for each of these z-scores. Recall the formula is z is equal to x minus mu over sigma. We know two different z-scores. We know the mu, we know the sigma. We're going to plug in our values into two equations and solve each one. Negative 0.84 is equal to x minus 55,000 over 7,000. And again, the reason we're doing this is because we need to find the actual salaries, not just the z-scores. We're going to solve this equation along with a positive 0.84 is equal to x minus 55,000 divided by 7,000. We're going to go ahead and do the math. Would you shout out the lower bound of your salary?
I got it.
Yeah, I love it. What did you get?
49,120.
Yes, so x is 49,120 when we solve. Beautiful. Does anyone have the upper bound?
I also had that, unless you don't want me to say it.
No, go for it.
60,880.
Yes, perfect. Once you do the math, you should get 49,120 with the upper being 60,880. So the salary range of the middle 60% of the workforce, I'm writing and thinking at the same time, of the workforce is $49,120 to $60,880. Excellent. With only 2 minutes left, I feel very confident that you can complete the very last section of this. So if we turn the page, there's only one more practice problem, and that is to determine the salary that separates the bottom 2.5% and the salary that separates the top 2.5%. Keep in mind that you are still given, you're still using the mean and the standard deviation from the previous problem. So I'm just going to write it here again for you. We're going to use the exact same values. And you're going to figure out the salary that separates the bottom 2.5% from the salary that separates the top 2.5%. All right. I would love for you to take this home with you. I am going to, like I said, I am going to record the next lecture tomorrow, and I will be sending that out to you all so that you can watch at your leisure prior to Monday's class. All right. Excellent work, everyone. That was fantastic. As always, if you do have questions, let me know. We can always meet to work on that together. Thank you. I will see you on, what's today? Wednesday? I'll see you Monday.
Thank you. Have a great
Thank
weekend.
you.
Question.